A hidden flaw is sweeping through the R-Vee industry, and it's costing owners thousands. 8 popular R-Vee models share the same catastrophic weakness, all tied to factory shortcuts that should have never made it past inspection. These tiny decisions, a misplaced clamp, a tight compartment, a cheap housing, are now triggering a $1,900 control module failure long before the warranty runs out. But here's the part nobody expected. These failures leave almost no trace. They build quietly through heat, vibration, moisture, or pressure, until one day your furnace shuts down, your water goes cold, and your R-Vee refuses to reset. We're breaking down exactly how these shortcuts formed, and which models are at the highest risk. Let's begin with Forest River, Salem. 26 DBUD. Some issues stay hidden until the evidence finally pushes through, and that is exactly what keeps bringing the Forest River Salem 26 DBUD back into the spotlight. Behind the smooth interior walls and bright showroom lights sits a shortcut that never should have made it past inspection. The plumbing feed that ties the water system into the heater relies on a single clamp connection, and that tiny decision has created more real trouble than many owners expect. When pressure changes hit that line, the stress sends a shock straight through the module, forcing it into thermal shutdown. And once that happens, the board rarely revives. The repair involves replacing the control unit that now averages around $1,950 in parts and labor combined, and that cost lands without warning. What makes this situation frustrating is the pattern. Repair logs from independent technicians keep showing the same sequence: a spike, a shutdown, and a dead control plate. A few owners catch a faint smell near the cabinet bulkhead right before the system fails, but most discover the problem only after the water temperature drops to nothing and the reset button refuses to engage. Heat signatures from several service invoices confirm that the module overheats long before the safety shell should allow it, which tells you the internal load is climbing faster than intended. When a board hits that threshold repeatedly, the solder points weaken, and once they separate, the entire furnace and heater chain locks out with no partial function to buy time. Understanding why this failure matters comes down to simple economics. Pressure-related damage gets tagged as user driven by many service departments, and that ruling shifts the entire cost onto the owner. Extended coverage often excludes what they call inconsistent pressure events, and that language effectively erases any chance of relief. Even worse, the factory design did not change quickly, so multiple years of this model carry the same weak point. Anyone looking at the Forest River Salem 26 DBUD should check whether the water feed has been refitted with a dual clamp or reinforced coupler, because that small upgrade often prevents the buildup that destroys the module. Now that you have a sense of how one shortcut leads to shutdown, the next model shows how a heat pocket can do the thing for an entirely different reason. Keystone Springdale 240BH. Trouble often reveals itself in small, stubborn signs, and the Keystone Springdale 240BH has one of those signs built directly into its heating compartment. Hidden behind the panel near the furnace housing sits an ignition module, positioned far too close to the primary heat channel. That placement was meant to streamline assembly, yet it created a temperature pocket the board was never engineered to survive. During long travel days, the chamber climbs past the safe threshold, and once the heat saturates the module, the internal layers begin to distort. The warping does not announce itself with a pop or a flash. It shows up through slow drift, a faint smell, or readings that flicker before the system collapses. When the board finally fails, the repair often hovers near 1,950, and that number hits hard because most service departments classify thermal deformation as environmental damage. That ruling blocks warranty coverage, leaving the owner with the entire bill. What makes this issue so distinct is the pattern found in shop logs. Independent technicians keep reporting discolored backing plates and softened housings on units well under the 2-year mark. Temperature scans taken during diagnosis show sustained levels above 165 degrees, even though the original design rated the enclosure for far lower tolerances. Once the module endures repeated cycles at that intensity, the solder points weaken, and any mechanical stress from road vibration finishes the job. Resetting the switch does nothing because the internal logic has already burned, leaving the furnace locked locked out and the water system unable to ignite. The explanation traces back to a compartment change introduced during the supply bottlenecks of recent production years. By tightening the space around the furnace, Keystone reduced material use and assembly time, but the airflow path narrowed. Heat can no longer disperse. Instead, it pools against the very component responsible for regulating ignition. The shortcut saved minutes on the line and added hundreds of dollars to repair invoices down the road. Anyone evaluating a Keystone Springdale 240BH should check for updated shielding, expanded spacing, or a relocated module. These fixes prevent heat buildup before it snowballs into deeper failure. A quick inspection now often means avoiding that steep repair later. As we move forward, the next model shows how airflow is not the only danger. Sometimes the weakness begins with structural bending long before the system even reaches full temperature. If you want more breakdowns like this, take a moment to like the video and subscribe. It helps. Keep this kind of information coming. Share your experience in the comments, because real stories reveal patterns the factories never admit to on paper. Jayco Jay Flight SLX 264BH. Some problems begin with a sound, some with a smell, and some with nothing at all. The Jayco Jay Flight SLX 264BH carries an issue so subtle that most owners never see it until the damage is already sealed into the frame. The furnace housing in this model was trimmed down during the parts crunch of recent production years, shifting from a thicker protective shell to a thinner, more flexible enclosure. That change saved manufacturing time, yet it introduced a weak point the system was never designed to manage. When the furnace cycles at full output, the reduced housing begins to bend, creating a slight distortion in the airflow path. The air no longer travels cleanly across the heat sensor. It ricochets, stutters, and drifts, and that unstable movement is what triggers the board into a safety lockout. Once the board enters that mode, it rarely resets. The module typically requires a full replacement, and that replacement often lands near $1,950 once labor and diagnostics are added. Technicians working independently have tracked the pattern across multiple service logs. Units under the 3-year mark show premature warping in the housing, with temperature readings climbing well beyond what the assembly should allow. Even a small bend shifts the alignment of the heat sensor. And once that sensor misreads the output, the entire system reacts as if there is an immediate safety threat. The module responds by shutting everything down at once. The owner experiences a sudden loss of heat and water temperature, followed by an error state that refuses to clear. The board does not fail gently, it fails completely. The reasoning behind the shift becomes clearer when examining the production environment. During the supply chain disruptions, Jayco sought lighter materials that could be sourced consistently. The thinner housing fit that need, but the long-term consequence arrived in these early failures. Heat is unforgiving. It finds the smallest weakness and exploits it until the system collapses. A housing built to the lower specification simply cannot maintain its form through repeated high output cycles. Anyone inspecting a Jayco Jay Flight SLX 264BH should look closely at the furnace compartment. A reinforced housing or upgraded airflow shield can prevent the distortion that leads to board failure. A simple correction early on protects the entire heating chain later. With that in mind, the next model demonstrates how confinement alone can trigger the same outcome, even when the materials themselves never bend. Coachmen, Catalina Legacy 243 RBS. Heat does not always roar or flare. Sometimes it gathers in silence, inch by inch, until the damage is done. The Coachmen, Catalina Legacy 243 RBS carries one of those slow, concealed problems deep inside the converter compartment. At first glance, the space looks ordinary, just another enclosure, tucked behind the service panel. But the moment technicians began running thermal scans, a pattern emerged. The compartment was far too tight for the equipment inside, leaving almost no room for airflow. As the furnace and water system cycled through normal use, the temperature inside that cramped cavity climbed higher and higher, often holding near levels that should never touch a control board. Once the heat settles into that space, the module inside begins to struggle. It flexes, then overheats, then drops into failure. And when that happens, the repair usually falls near $1,950 once parts and diagnostic hours are added. What makes this issue more troubling is the ripple effect that follows. When the converter overheats, it does not simply damage itself. It pushes unstable current through the surrounding electrical lines, sending inconsistent voltage into lights, fans, and outlets. Owners have reported dim ceiling bulbs, flickering fixtures, and appliance resets long before the module finally shuts down. Those signs are not random quirks. They are warnings that the system is being strained by temperature levels it cannot tolerate. Once the board reaches its limit, it locks out entirely. The water heater refuses to ignite. The furnace stalls. The cabin drops to silence, and nothing short of a full replacement brings it back. Technicians digging through service records noticed another detail. Many units showed discoloration around the module housing, a sign that repeated exposure to temperatures above the rated threshold was wearing down the internal components. These readings often came from units that were still relatively new, which ruled out age as a suspect. The true culprit was the narrowed compartment, introduced during a layout update. By tightening the space around the converter, the design restricted ventilation and created the perfect environment for heat accumulation. It was a shortcut that traded convenience of assembly for long-term reliability, and owners became the ones paying for that compromise. Anyone examining a Coachmen Catalina Legacy 243 RBS should look carefully at the converter housing and ask whether upgraded ventilation or an aftermarket shield has been installed. A small adjustment now can prevent the cascading failures that start with heat and end with a costly shutdown. Ahead lies a different kind of weakness, one shaped not by temperature, but by moisture that slips in unnoticed until the damage is already set. Heartland Mallard SEN 85. Moisture has a way of slipping into places where no one expects it, and the Heartland Mallard 185 carries a flaw built around that exact kind of intrusion. Behind the bathroom wall, a narrow adhesive strip replaces the kind of sealed corner seam that should have been used from the start. At first, the difference looks minor, almost harmless, but that change opened a path for steam to migrate through the joint every time the shower runs or the air grows heavy after cooking. Steam turns to condensation, and condensation settles on the metal surface of the control module fixed behind that wall. Bit by bit, droplets collect along the terminals until corrosion forms, and once that corrosion begins, the board never fully recovers. The system drops into failure without warning, and the repair often comes in near 1,950 once labor, testing, and replacement are factored together. The troubling part is how quiet the damage remains during the early stages. Owners describe no odd sounds, no burnt smell, and no flickering lights. Everything appears normal until the furnace refuses to fire or the water refuses to heat. By the time the panel is opened, the evidence is already etched into the hardware. Technicians studying damaged units consistently find oxidation spreading across the board's lower contacts, a sign that moisture crept in gradually rather than through one event. This pattern eliminates the usual suspects. It is not a spill, not a leak from above, and not a failed seal on the exterior. It is trapped humidity moving through a seam never meant to carry moisture. Understanding the source leads back to a production shortcut introduced during the rapid build cycles of recent years. When demand climbed and material shifted, Heartland implemented a quicker adhesive solution along certain interior walls to maintain output. The intention was efficiency, not long-term failure, yet the result undermined the reliability of the heating chain. Steam does not respect shortcuts. It finds them, works through them, and settles wherever temperature allows. A control module positioned directly behind that seam becomes the first casualty. Anyone reviewing a Heartland Mallard 185 should inspect the bathroom wall junction carefully. A proper sealed seam or moisture barrier can keep condensation from reaching the module. Correcting the weak point early prevents the steady creep that leads to a full shutdown. As we continue, the next model exposes a different threat entirely, built not on moisture, but on vibration that strikes every mile of the road. Before we go deeper into the final models, make sure you are subscribed. These failures often surface quietly, and upcoming reports will help you stay ahead of them. One click ensures you do not miss the updates that protect your time and money. Gulfstream Ameri-Lite 268BH. Road vibration exposes weaknesses that still air can hide, and the Gulfstream Ameri-Lite 268BH carries a weakness that begins the moment the wheels start turning. Inside its heating system sits an ignition module, originally designed for stationary units, a component meant for equipment that never shakes, bumps, or flexes. That decision alone created a problem that owners never saw coming. Each mile sends a ripple through the frame, and those vibrations travel straight to the module. Inside that module are delicate solder points, thin connections meant to stay still. When constant shaking begins bending them, small fractures start forming, and once a fracture grows, goes, the board loses its ability to ignite. There is no half failure. The system simply stops, and the repair often lands near 1,950 after diagnosis and replacement. Technicians who have opened these failed units keep finding the same signature. The solder joints along the lower edge show tiny cracks, some barely large enough to see, yet large enough to break the ignition circuit entirely. These cracks do not come from heat, they come from motion. Independent repair reports show that many failures appear in units with fewer than 10,000 miles of travel, which tells you the stress comes early and builds with every hour on the road. Because the module was never rated for mobile use, service departments frequently mark the damage as vibration-related, a classification that immediately places the cost on the owner. The deeper frustration comes from how preventable the problem could have been. A mobile-rated module uses reinforced internal supports and thicker solder points designed to withstand long travel days. But the substitute part used during production shortages lacked those protections. It met the minimum requirement on paper, yet it was unsuited for the environment it was given. The result is a long line of owners experiencing sudden heat loss, water systems that refuse to ignite, and error codes that reset for a moment before failing again. Anyone looking at a Gulfstream Ameri-Lite 268BH should inspect the furnace compartment and verify which module code the unit carries. A properly rated replacement eliminates the vibration issue entirely, sparing the owner from the abrupt shutdown that appears without warning. Ahead, the next model shows how electrical surges can take out the same component in an instant, even when vibration and heat are fully under control. Winnebago Micro Minnie 2108 DS. Electrical systems fail in different ways. Yet, the Winnebago Micro Minnie 2108 DS often fails in a way that feels instant, sharp, and deeply avoidable. Inside this compact frame sits a slide controller, designed with a rating that never matched the demands placed on it. When the slide meets even mild resistance, the controller draws more current than intended. That surge spills through the connected heating chain and pushes the control module past its tolerances. The module reacts the only way it can. It shuts down, locks out, and leaves the owner staring at systems that refuse to start. Once the board reaches that point, the repair often falls near 1,950 after diagnostics, parts, and travel. Time, and that cost arrives without mercy. Technicians examining the failed units report a consistent pattern. Slide motors spike beyond their expected draw, sometimes reaching levels no module in that position should ever experience. Instead of containing the surge, the controller passes it along. The board, built for steady regulation rather than sudden jolts, absorbs the shock and overheats internally. The damage is not always visible. Some boards show discoloration, while others appear nearly untouched, despite being fully compromised within their circuitry. Resetting the system provides no relief because the failure comes from logic layers that have already collapsed. This issue began when lighter controllers were added during recent production cycles. They eased installation, but removed the buffer needed for real travel loads. A small incline or tight seal forces the slide to draw more power than the low rating allows, sending damaging surges into the module. Checking for an upgraded controller prevents those spikes and protects the entire heating chain. Ahead lies the final model, one shaped not by weight or motion, but by the placement of wiring, where heat should never travel at any point. Thor Compass 23 TW. Heat leaves a signature long before it becomes a failure. And the Thor Compass 23 TW carries a design choice that allows that signature to form in one of the worst possible places. Running alongside the main furnace duct is a wiring harness that should have been routed with distance and insulation. Instead, the harness sits only a few inches from the hot airflow path, close enough for repeated cycles to soften the protective coating and weaken the connectors underneath. That softness becomes the beginning of a long, hidden decline. With each heating session, the insulation warms, then cools, then shifts. Over time, the terminals begin to move, and once they loosen, the control board takes the impact. The module tries to compensate by restarting, recalibrating, and forcing its internal components to work harder than designed. Eventually, the strain becomes too much, and the board fails outright. When it does, replacement often approaches 1,950 once inspection, labor, and the new module are included. Reports gathered from independent technicians reveal consistent signs of this slow structural failure. Many Compass units show a light browning along the harness exterior, an early warning that most owners never see. Others exhibit small cracks in the insulation, allowing heat exposure to reach deeper layers. Each time the furnace engages, the harness absorbs another wave of warmth, and every wave pushes the system closer to failure. Once the connection points begin to drift, voltage irregularities appear. Those irregularities send unstable signals through the heating chain, leaving the module unable to maintain a steady state. The shutdown happens quickly, but the damage forms long before the first error code flashes. This failure did not come from weak materials, but from a routing shortcut meant to speed assembly and cut cable length. That choice placed a sensitive harness beside steady furnace heat, which slowly softened insulation and loosened terminals. Once the harness shifted, the control board failed. Inspecting for rerouting, added shielding or extra insulation helps prevent this avoidable breakdown. If any of these models shocked you, or you've seen this failure up close, tell us in the comments. Your story might be the one that warns someone else. Make sure to like the video so more R-Vee owners see this before they get hit with a $1,900 surprise. And don't forget to subscribe. We've got more exposed shortcuts, buyer warnings, and insider breakdowns coming very soon. Thanks for watching, stay safe out there, and keep your rig protected.